Hello, and welcome to the Supplemental Office Hours video, where today I'm going to be going over strategies for reading and writing a research paper. Specifically, we're going to be going over these two papers by Carey and Kording and Mensh, respectively. As we focus very heavily on reading and writing three research-style papers for this course, we felt like this is a great method of giving you a nice foundation, especially for people who have never really interacted with academic or research-style papers. One of the main reasons why we tackle and focus on specifically academic papers, it is part of the course objective to really develop the basic skills necessary to pursue research in reinforcement learning. Many people might have qualms about this aspect of the course. However, I really want to challenge the notion, as this field is so new and textbooks and coding examples might not be readily available. Additionally, this universal standard method of communicating in a peer-to-peer manner with research and academic sense has been deeply established, and it takes a little bit of skill to be able to consume and then communicate yourself, but they're give you the ability to venture deeper into topics that you might find interesting. Just from this graph, for example, the topics in machine learning, artificial intelligence, deep neural nets, and robotics really have exploded in the last decade, and it's imperative to know how to read and write these papers to be able to venture into some of these new topics. We wanted to break it down and give sort of a very high level overview in the four different types of paper where they have descriptive, analytical, persuasive, and critical. Each of these can be subcategorized in a variety of ways, but the main types and length delineation between types of research paper are conference, journals, review papers, topics, trends, and opinions. Specifically, conference papers will be around 4 pages to 8 pages, depending on the conference, where journals can be somewhere between 8 to 50, perhaps, depending on the supplemental. Review papers tend to be a lot larger, like chapter reviews in books, so potentially roughly 30 pages, where I've seen some go up to 70. And then opinion articles are more for the editor and senior researchers in the field who might elucidate on something that might be interesting to the field to know, depending on the journal. So what we're going to be going through is we're going to start with 10 simple rules for reading a scientific paper. One thing I want to point out are the authors of the paper, as it is a great idea to always look to see who's actually trying to communicate, as a research paper is a two-way street, whether or not that person is in the same room with you is not. So here, Maureen Carey is from University of Virginia. She was a graduate student in this lab and a main contributor with William. Kevin Steiner is an infectious disease specialist in Columbia, but specifically William Petrie is a physician scientist at the University of Virginia, where he has developed FDA approval of some vaccines for very specific types of microbes. He is the highest funded research in the School of Medicine, and under his leadership, the division had annually research funding had increased from about $500,000 to $19 million a year, making it the highest externally funded program at the university. So in terms of writing scientific research, writing grants, I would say that this team has specifically great expertise in this field, and we can take their advice in with knowing that these are all experts. The first rule that they start is picking a reading goal. Here they outline 5 different sort of ways in different intentions that you might have. These are the types of things you want to get out of an article and really should influence how you approach reading it. Table 1 here really indicates a handful of examples in how you might prioritize the different parts, and specifically based on your goals as a reader. For this course, we're specifically going to be focused on the first 2, where you're either new to a scientific paper or you're entering a new field where more depth is going to have to be delved deeper into sort of the paper details, as you might not be as familiar with either terms or styles of writing or particular examples or common metrics or various things that might pertain to the paper writing itself. The second rule is to really understand the author's goal. In written communication, the reader and the writer are really equally as important. And so both influence the final outcome. And so in this case, it's your scientific understanding. With this, and after you establish your goal, you want to think about the author's goal, as they had an intention to be able to communicate out to the world. This will help you interpret the data and really the author's interpretation of the data. However, this really requires understanding of who the authors are, what their scientific interests are, the scientific field in which they work in, what kind of techniques that they have, and how the paper really fits into this author's research. Meaning it could be a long-standing paper that they've decided to conglomerate together to a seminal work, or it's just a building block at a conference, perhaps, where they're trying to get more feedback potentially from peers. And so with this information, it might be hard to glean experience and history of reading, but please don't take this as a disencouragement to start the reading process. I know we start very basically with Sutton and try to work our way up from the 88 paper. And so many of the papers that we will read subsequently will build off of these foundations. A good step to understanding yourself into understanding the authors is what is this article about? Journals publish different types of articles, including different methods, reviews, commentaries. So it's great to understand where this fits even in the journal. Great. And so moving on to the third rule, and I think probably the more important rule for this paper, is to ask these 6 very important questions. And you here can read all the way through, but at every stage of the reading a paper, if you can answer all 6 of these questions, you'll be able to move on and have a clear understanding. If there are potentially a hiccup in potentially how do the results show the figures in the data, you might need to go back and sort of try to look at it better. Or even how did the author interpret the data? Are they missing a piece? Try to really highlight those areas and see if you can pick it out and answer these questions. For each of them, you should be able to ask about the tables, the figures, the experiment, and even the whole paper itself. It can really take a long time to read an article front to back. So this way to break down each section by questions will help make the effort more manageable. So unpacking some of the figures and tables, scientists write original papers primarily to present new data that may change or reinforce the knowledge in a field. Therefore, it's really important parts of the scientific paper are the data and figures. Some people really like to scrutinize the figures and tables before reading any of the main text, because this is really the important part and the meat of the paper itself. Others prefer to read through the results section while subsequently examining the figures and tables, and sort of they address the text as well. So there's really no right way of going to it, but typically the figures are part of the first pass, and especially a priority when you're trying to initially understand it. For each figure, really work to understand the X and Y axes, the different color scheming, statistical approach, and why the particular plotting approach for use. Here we see that this is a paper from David Silver going through more of the improvements to AlphaGo algorithm in 2017. We have a 3-column figure here going over the 3 different games that they are trying to create an optical performance agent on. Here they have great text going through what they've done, and the color scheme is very clear as they chose primary colors for the use of delineation, especially if it happens to be printed in black and white. So here, don't be afraid to potentially revert back to the methods section. Here we don't really understand what alpha Lee and alpha Go 0 might differ from each other. Perhaps even they might have a better reasoning why the AlphaGo Lee might just be a horizontal line. That's not necessarily explained here, so reverting back to the method section would be great. And then additionally, just to highlight, going back to the 3 rules, or the 6 rules from the 6 questions from Rule 3 is going to be great when tackling these figures. So what you want to do next is to understand the formatting intentions. We will go through this later in the next paper, but this specifically indicates how the structure of a paper is written. Just like the intentions of the author, the structure is also an intention, and they might be to be objective descriptions of the data, or others might be the author's interpretation of the data. But they're all labeled title, abstract intro, methods, results, discussion, and conclusion with a reference section. And if there are ambiguities between different types of scientific papers or different journals that you might find, always revert back to the journal's website, as they will have all the paper specifications and what needs to potentially go into what section. The next thing is to really be critical. Published papers are not truths etched in stone. They are not papers that are in high impact journals are not truths etched in stone. Giving big wigs in the field, they're really not truths etched in stone. This paper repeats this line, truths not etched in stone. I can't stress enough that not all papers are good, and that's okay. Science is a never-ending work in progress, and it is essential that the reader is critical when consuming and pushes back against the author's interpretation to really trust their own convictions and conclusions. Everybody has their own perspective, and they might interpret the data differently, and sometimes the mistakes can be published. We really have a lot of issues when even trying to write many of these reports. There's a lot of limitation on methodology that can be explained. Some things might be too generalizable. There might be selection bias, unaddressed or inappropriate confounds to the data or even your methods. So always be critical, never really take things at face value. One thing that I always note is in research and academia, people need funding and grants need yearly updates. Unfortunately, sometimes research does not work on a biannually, annually, or even monthly basis. However, people still need to show some things. So a lot of times I will come across papers that are grant fulfilling, which means that they make very high claims, and potentially the results don't necessarily show as impactful of a claim that they might make. So always be very critical about how you read things and how you're interpreting the data. Critical thinking in this skill specifically might be tough, but it ultimately boils down to just evaluating the data to try to minimize the bias as much as possible. Great. With being critical, though, I can't stress enough about trying to be kind and keeping good intentions and positivity at the forefront of your critiques. Authors are human too, so whenever possible, try to give them the benefit of the doubt. They might be writing a phrase differently than you would, or forcing you to reread a sentence to understand it just because of the jargon that they wanted to add in there. But at the end of the day, they are people, and if you're critiquing others and their work, try to be extra kind. They will have the best intention and hopefully trying to just better the field and provide more critical thinking and critical examination of the topics at hand. With reading a paper, you really need to make sure to go the extra mile. Types of things that you might have to do is to look up terms that you don't know, dig into supplemental material, or even read one or more of the cited references. I find myself looking at papers and end up looking at 4 because I needed to go look up a methods paper or a review paper or understand a concept that they try to bring up in a methods section, or say obviously because of this, and I'm like, I didn't think that was obvious, so I have to go look at the paper. This process really does take time, and some advisors recommend reading an article 3 times, which I also recommend. Specifically, the first time I read an article, I will read it without pressure of understanding or critiquing the work. I just want to get through it. I need to read every section, understand where the figures are and how they might relate. Where the second time I go through it is for an understanding. Here, I will take notes. I will mark up the whole paper and circle terms that I need to go through. And then for the third time, I will deeply go through it and try to highlight my misunderstandings and start to go through other papers that might be related to the paper itself. Not everybody needs a paper copy. I have actually started to go more digital, especially over the COVID pandemic, where I didn't have access to a printer as easily. And so what this is trying to say and ultimately boil down to is you need to be active with the paper. You just need to have a way that you're engaged and able to consume potentially some of the finer grade details. Because unfortunately, many of these papers are not going to read very linearly, and you're going to have to really wrestle with it as you try to get your understanding. The next big rule is to just talk about it. Really try to organize yourself to be able to discuss very comfortably with it. Talking about an article really in an informal environment forces active reading and participation with this material, which studies have shown that this technique is the best way to learn and that teachers actually learn the material even better as they teach and become more complex. Anecdotally, such observations inspire the phrase, to teach is to learn twice. And so try to go beyond the formal setting of just reading it by yourself, come to office hours, really try to engage with the material. If you have a sibling or if you have a partner or parents or anybody in the house, children even, and they're interested in hearing about any of these topics, you can start from ground zero and sort of work your way up. This is also great. One way that I find myself trying to do this as well is I'll take a half hour and record myself going through a topic and to see where I'm at and play it back at 2x speed. I know there can kind of be some weird recording yourself and speaking qualms and hesitations with this method, so it's not for everybody. The last one on this one is to make sure you build on where you start. Whether you're reading an article to understand the topic or move into a new research project, effective learning requires you to integrate knowledge from multiple sources and build upwards. You really want to leverage the published works. And so essentially, you want to take the conclusions that you currently have, make sure you make notes of it, summarize what you have, and then build on it. As you actively consume more papers, you're going to have your own method of doing this. And hopefully these rules are a great way in a foundation to you to start to read the paper. So next, we're going to go over some rules on how to write and structure your paper. Here, I want to highlight the authors as well, as understanding who the authors are is a great way, again, to very early start in consuming your papers. Conrad Kording, he's currently at the University of Pennsylvania. He is a Goliath in the computational neuroscience field. He is known for motor control, neural data methods, and a lot of the complex computational methods for neuroscience. Brett Mensh is also a collaborator, and he works at the Genelia Research Campus doing motor control and specifically fly work. So as an overview, these are the 10 simple rules for the structuring of the paper. It is broken up into 3 different sections, and we will be going through each one of them iteratively. So the first rule is to present only one contribution per paper. And this is specifically communicated through the title. It is the absolute most important piece of writing that you will have towards a paper, regardless of any of the content. Only because of the searches that you'll have on search engines, the way that people will try to find your paper, how this communicates your central idea as central as possible. So you want to think of the ratio of the number of titles you potentially read, or even the number of titles or number of papers you read. And it's going to be vastly skewed to just the title. So when writing your title, you want to absolutely try to synthesize your research as succinctly as possible. For our case here, we don't necessarily need to worry about this, as many of the times it'll just be project 1, project 2, project 3, exploring X, Y, Z. So we, in this class, we don't stress upon it, but if you're writing your own original research, absolutely most important piece. Second, and this one is very important, is that you really want to write for flesh and blood humans who don't know the rest of your work. Because you're the world's leading expert on what exactly you're doing, you're also the least qualified person to judge your own writing from the perspective of the naive reader. The majority of writing takes mistakes from this predicament specifically. If you think like a designer, for each element, determining the impact you might have on the people, and then strive to achieve the objective. So as you think through the paper like a naive reader and grasp the measures, the vast knowledge of the base of the human psychology is useful for paper writing. However, people do have working memory constraints. They can only remember a small number of things and are better at remembering the beginnings and ends of lists than the middle. So understanding some of these qualms, we would like you guys to write for the TAs who don't know your face. We are trying our best to interact with as many people as possible via Slack, Piazza, office hours. And for those of you who are turning your cameras on, we're trying to get a little more. But for a majority of you, we will just not know your face. So we ask you to sort of think and try to understand and give us some grace when writing, and especially not making assumptions that we just sort of assume that you might know this. So if anything, being more verbose is better than being less verbose. I would like for you all to, or one of the best, okay. So one of the best ways to write is in the context, content, conclusion scheme. A vast majority of popular stories have structures with a discernible beginning, a well-defined body, and an end. The story sets up the contents, or the beginning sets up the context for the story, while the body advances the story towards the end, where the problems find their conclusion. This structure reduces the chance that the reader will wonder, why was I told that? If the context is missing, for example, or so what if the conclusion is missing? So understanding that you need to have all three of these sections to tell a complete story is important when writing your methods. Rule 4 is to try to keep a logical flow, and especially really avoiding zigzagging and using parallelism. I have two examples here. And one is sort of a, and I've seen both of these papers in this course. The zigzag structure here is specifically where you'll have either 3 methods to try out or a couple graphs to reproduce, and you'll go systematically graph by graph to try to produce both the theory, applications, results, and the discussion, all trying to contain in that one section. This makes it more difficult for a reader to try to go back and forth, especially if we're trying to compare and contrast some of these methods in more of an understanding. So the non-zigzag structure really sticks and focuses in trying to have the method sections, the theory, applications, discussions, and conclusions all separated and delineated. This way, it'll help both the flow of the reading and the reader and the grading. Paper flow is outlined here in this pictograph. We're going to go through each of them piece by piece in the next rules. So telling a complete story in the abstract. The abstract here has the context, content, conclusion paradigm. And we must really fill the gap, or the content must really fill the gap that the paper needs to fill. The first sentence orients the reader by introducing the broader field in which a particular research is situated. Then the content is narrowed down until it lands on the open question that the research is answered. Here, so the one question is, here we do what we found. An accessible content section sets the stage for distinguishing the paper's contribution from the current state of the art by communicating what is missing in the literature, i.e. the specific gap, or why this matters, or the connection between the specific gap and the broader area. The content here we first describes the novel method or approach you use to empower your answer to the gap question. You then can present the meat of your paper, your executive summary of the results. Avoid the words with highly technical meanings, including different jargon, as use of these words will be subtle for meanings as possible. Finally, when the conclusion interprets by the results, the answer to these questions will be posted by the end of the content section. Then especially for more general journals with broader readership, there's really only a second part to this conclusion section, which highlights the conclusion to move into the more broader field, but we don't need to matter about this. Really keep it in the IEEE standard, where how it matters is the conclusion for the abstract. Get across why the paper matters in the introduction. So here we have the pictograph highlighting that the gap exists in the current knowledge or method, and you need to show why this is important. It's usually done by a set of progressively more specific paragraphs that culminate into a clear exposition of what is lacking in the literature, followed by a paragraph summating what the paper does to fill this gap. As an example of the progression of graphs, the first paragraph might explain the understanding of potentially cell differentiation, an important topic in the field that might not be solved that triggers a gap field. A second paragraph might explain the unknown about the differentiation of the specific cell type, such as astrocytes, a subfield gap. The third might cue a particular gene that might drive astrotic differentiation when then state that this hypothesis is untested by others in the field. This gap statement then sets the reader's expectation for what the paper will deliver, which is a study about the gene for the specific astrocyte in the differentiation of different cells. This structure of each introduction paragraph subserves the goal of developing for the gap. And as you conclude, and as you continue, you really want to show and establish where someone might be able to revert back to if they need introduction from the beginning literature. In the results section, for Rule 7, you want to communicate a sequence of statements that build on one another to support the central claim. Here we have a great illustrative example where we have logic 1, where the raw data gets processed with the final statistics. Here, this goes into telling the story, and then with figures, you want to tell the whole story. And so in this outline, this paper sketched the logical structure to support your claim and convert this into a sequence of declarative statements. And so as you go through your conclusions of the previous paragraphs, which your theorem should build on for the mathematical literature. In Rule 8, you want to discuss how the gap was filled, the limitations of the interpretation, and the relevance to the field. The discussion section explains the results which the gap identified in the introduction, provides caveats to the interpretation from your results, and describes really how the paper advances the field by opening new opportunities. I can't stress enough how important the discussion section is, especially for this course, as this will show and demonstrate more of your understanding towards the material and your experimentations itself. Some readers try to skip over substantial parts of the results, so understanding a clear discussion section will help the reader interpret why this story even matters. Each of the following paragraphs in the discussion section really starts by describing an area of weakness or strength of the paper. It then really evaluates the strengths and weaknesses by extensively linking to relative literature. Lastly, the discussion section concludes about the author's way of perceiving the contributions and then potentially discussing ways for going forward. And as you can see here in the pictograph coloration. With that, that'll complete what the paper is constructed of. However, one important thing is to know time management. I cannot stress enough, this is where majority of the problems occur when writing papers. You want to write early and write a lot. You always want to be able to trim down your paper rather than having to build up. In terms of where you spend your time, you would always want to spend time with the title, abstract, figures, and outline. With this course, we more or less suggest starting with an outline, as the title and abstract will not necessarily play a huge role, if any, for the final grade. We're looking for more of your figures, your outline, in how you structure the paper with a very comprehensive discussion. Finally, just to wrap things up, we always want you to iterate. Don't be satisfied. Try to get feedback, try to come to office hours, post on Piazza, see if you can get your roommates or parents, partner, children to read your papers, as it'll always help your own work and synthesizing your thoughts better in a better communicative way. And as you keep going, please feel free to reach out to us. I know many of this can probably drive many inquiries onto potentially what we're looking for, or different strategies on tackling different sections of the paper. But that is it for this presentation. Hopefully we will discuss some of this in the office hours, but if you do have any questions, feel free to post on Piazza under this link. Thanks everyone. Talk to you soon.